Okay, so on this example, they're giving us the piecewise functions in three different pieces, and they're asking us all about continuity. Best thing to do is to graph. So let me go ahead and I don't mean graph the whole thing all perfect and everything. I just mean get a general idea what's going on here. Um, so they're giving us the point -1, which I'll just put that right there. -1, +1, +2, +3, etc. So, because it's all about -1, notice. All about x is on the x-axis, -1. So what do we have going on there? Well, this is less than -1, so that's left of -1. I'm just going to plug -1 in right there for x. You're going to get negative, the negative sign that's already built into the formula, -1 plus 1. That's going to be what? 1 plus 1, 2. It's going to be 2, which means the function's at a height of 2. So from the left side, it's coming. I'll put an open dot there because you might be wondering, Mr. Aaron, why'd you plug in -1? It's not equal to -1. I know, but it's infinitesimally close to -1, right? It'd be like -1.00001, really close. So I can plug in -1. Two negatives make positive. 1 plus 1 is 2. So it's at a height of 2. This is 1, 2. But it's an open dot because it doesn't exactly touch there. Now, right at -1, it hits at a height of 1. So it's right here. Here's the solid dot right at -1. Okay, last part. When it's greater than -1, that's to the right of -1. I'm going to plug in -1 again, even though it's not exactly right on -1. It's infinitesimally close. So that'll be -2 times -1 minus 4, which is what? 2 minus 4, -2. So it's down here. 1, 2, it's here. And then I don't know what it does, whatever, to the right. So on the right side, it's at a height of -2. So on the right side, it's at a height of -2. On the left side, it's coming in at a height of +2. And then right at the point, it's hitting the height of 1. Okay, so what does that mean? Is it continuous? No, 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 it's not. Continuous means, what does continuous means? It means you don't pick up your pen. Continuous, continuous, you can trace the graph and not pick up your pen. You can continuously trace the graph. You can't do that one. You have to go here, you'd stop, put your pen here, stop, go down here, right? So that's not continuous. So we'll say no to that first option. And why is it not continuous? Because f of -1 does not exist. Um, no, f of -1 does exist. It's right there. Right? There's a solid dot there. That's not the reason. Okay, is it not continuous because the limit does not exist? Yeah, and you can see it down here. That is the answer. Why? Why is that the answer? Because remember, a limit to for a limit for a limit to exist at a point must be the same height from the left and the right. So for a limit to exist at a point, it's got to be coming in the same height. So from the left and from the right, it's coming in at different heights. So that's the problem. That's why it's not continuous because the limit doesn't exist there. It's not coming in the same height. Oops, from the left and the right. It's coming in at different heights. So how could it possibly be continuous? The last one says it's not continuous because f of 1 and the limit exists. No, the limit doesn't exist, but are not equal. No, no, no. The limit doesn't exist. A limit only exists if it's the same from the left and the right. So that's the problem. It's not the same from the left and the right. So they're not even meeting. How could it be continuous? And so there we go.